Hello folks, here's our problem for today. Compute the least positive integer with 7 digits and exactly 7 positive divisors. How do you handle a problem like this? Well, the first thing you want to do is tackle the conditions. Okay, we're going to translate this math problem into math. So we have the least positive integer. So whatever number we have, we know two things, right? It has to be an element of the set of integers and it has to be positive, okay? So we already got two restrictions on our number. But there's an infinite number of numbers that satisfy this condition, so let's look for more. We have our second condition as the number has 7 positive divisors, exactly. Okay, so that means let's define a function d of x such that d of x gives you the number of positive divisors, gives number of positive divisors of x. Okay, so this is the positive divisor function. So if I put a number like 5, it would give me 2 because 5 is a prime number and the number of divisors of 5 is 2. So d of 5 would be 2. Okay, so the next condition we have is that our number has exactly 7 digits. Okay, so x has 7 digits. Okay, so these are the 3 conditions we have for our number x. So let me pick a chalk color right here. First thing you want to do is condition 1 is already satisfied, right? It's you can keep that in the back of your mind. How about condition 2? What do you do for condition 2? Condition 2, you want to think about the formula for the positive divisor function. If I have a number x whose prime factorization is p sub 1 e sub to the e sub 1 times p sub 2 e sub 2 all the way to p sub n e sub n, where p is a prime number and e is just a positive exponent, and this is the prime factorization of x, then d of x, the positive divisor function of x, is just going to be what? It's going to be e sub 1 plus 1, e sub 2 plus 1, all the way to e sub n plus 1. And of course you can check out the proof independently, but that right there is the positive divisor function formula. Okay, so we know that this has to equal 7 because we're told that our function, our integer x, has exactly 7 divisors. Well, if this is equal to 7, what must we also know? That means all of these guys have to be 7 and this one has to be 1, right? So that means e to the 1 has to be 6, and e2, e3 and all the other exponents, en, have to be 0. So really what we're talking about here, is some integer x that's a prime number raised to the 6th power. And we know it has to have at least 7 digits. Well, what do we mean by 7 digits? What's the kind of minimum integer it can be? Well, it has to be greater than 10 to the 6, right? 10 to the 6 is the smallest number with at least 6 digits, with at least 7 digits. But here's the thing. Let's use blue now. Here's the thing. The number itself, p1, cannot equal 10 because 10 is not prime, okay? Because d of 10 is greater than 2. Okay, it's not prime. But what can p1 be? It can be the next prime number bigger than 10. So what's the prime number bigger than 10? Well, p1 has to equal 11. And so therefore x must equal 11 to the 6th power. And that, ladies and gentlemen, is our answer. Thanks for watching this episode. We'll check you out next time.
Ambition plus MKO plus scaffolding equal learning. We believe anyone can learn anything. That's why our motto is memorization is a crime. And that's why we partnered with Brilliant.
Brilliant transforms math and science into hands-on activities so that you too can understand everything from first grade math to E equals MC squared. Barry Science Lab and Brilliant is your MKO, and will give you the scaffolding to expand your ZPD until you become the next Sir Isaac Newton or Albert Einstein.
Visit brilliant.org/Barry Science Lab today. And the first 50 of you to use that link will get a 20% discount on the Brilliant annual subscription.
Don't forget that you too can become the next Einstein. So let's fall in love with math and science.